So we're going to take a look at the prime factorization and a factor tree for 840, and then we're going to derive from that all of the factors of 840. So first let's take a look at the factor tree. We start with 840 and we break it into any two factors that make 840. So I just chose 84 times 10. And we're going to break 84 into two factors. I chose 21 times 4, and then I broke 10 into 2 times 5. 21 I broke into 7 times 3. 4 I broke into 2 times 2. 2 is already prime, so it comes down. 5 is already prime, so it comes down. So finally, we always end up on the last row with a sequence of prime numbers. And this is the product of these prime numbers is the prime factorization for 840. So what's amazing about this is that it tells us everything we need to know about 840. So here's what I want to do. I want to actually just add to this. I want to go through and make a list of all the factors. So we know 1 goes in because it goes in all numbers. 2 is explicitly in the list above. Now, if it's a prime number, it has to be in that list. If it's a composite number, we have to make it from the primes. So is 3 in the list? Yes, 3 is in the list. Is 4 in the list? And yes, it is. So we can see 4 as 2 times 2. And that's the only way to see 4. 5 is in the list. 6 is 2 times 3, so 6 is in the list. 7 is in the list. 8, 2 times 2 times 2 is in the list. 9 is not. 9 is 3 times 3, so we only have 1 3. It's not in the list. 10, 2 times 5. 11 is prime, so that's not in the list. 12, 4 times 3. 2 times 2 times 3, so 12 is in the list. 13 is prime, not there. 14 is 2 times 7. 15, 3 times 5. 16 is 2 times 2 times 2 times 2. So we're missing a 2, so no 16. 17 is prime, not in here. 18 is 9 times 2, not in here. 19 is prime. 20, 2 times 2 times 5. Now we're starting to get up there towards the top of factor pair mountain. We're not there quite yet. 20 times 20 is 400, so we know we're not there, but we're getting close. 21, 3 times 7, that's there. 22 is 11 times 2, so it's not there. 23 is prime. 24 is 8 times 3, 2 times 2 times 2 times 3, 24. 25 is 5 times 5, so it's not there because we need 2 5s. 26, 13 times 2, not there. 27 is 9 times 3, so it's not there. 28, 2 times 2 times 7, 28 is there. 29 is prime, it's not there. And let's see, 30 is 6, 2 times 3 times 5, so 30 is there. Now, 30, now here's what we're going to do here. I want to look at 30, so I'm going to, let's see, can I mark up and shade it? I want to look at 30 here. So this is 30, 6 times 5. And the amazing thing that we can do here is say what goes with 30. Well, what goes with 30 as its factor pair are the rest of the factors. So 2 times 2 times 7. And this can be done for any of these factors. We can highlight the factors we're looking at, and the other factors combined are the other pair. So in this case, this actually is our central pair for factor pair mountain. That's the summit. So then walking down the mountain, right, and I think I can just undo that highlighting. Undo. Okay, so we want to know what goes with 24. And maybe I'll leave this highlighting in here. This is the central pair. What goes with 24? Well, what goes with 24? 24 is this. 2 times 2 times 2 times 3. That's 24. So what goes with it is 5 times 7, which is 35. What goes with 21? Well, 21 is the 3 and the 7. What goes with that? The 5, the 2, the 2, and the 2. So that's 8 times 5, so that's 40. What goes with the 20? Well, the 20 takes 2, 2, and 5, so we're left with a 2, a 3, and a 7, so that's 21 times 2, so that's 42. And we can just work our way down the mountain, taking out all the factors for whatever number went up the mountain, and whatever's left is what comes down. And there's a whole big list of them because there's so many factors for 840. But what I think is interesting is using the prime factorization to find the factors, all of the factors for 840.